Kevin, thank you so much for being here. Welcome to the podcast.
Yeah, thanks for inviting me. It's a pleasure to chat. And I mean, in the past, I've done podcasts with other people, and it's been great to kind of share my work more broadly, different format. So I really appreciate the invite.
Sure. Thank you so much. So we are talking about data structures and algorithms today, and I want to start with just trying to understand and help people understand why DSA, are still useful in the real world and in the day-to-day work of software engineer, right? And because sometimes, they are not just needed to pass, I think, to pass lead code style interviews. So what's your take there?
Yeah, I feel like there's a lot of questions embedded in your question, or a lot of assumptions certainly, about like what the future of work will look like, what students want to do in their future jobs, right? Like this kind of alignment with software engineering in the first place, um, and how that could play out with like the curriculum. So I think considering all those three pieces, there's a lot to say. I think if we take your assumptions, so we start with your assumptions, we continue down that path that you've set up here. I feel like there's an interesting set of questions around like you were mentioning, this question of like, what's the value of data structures and algorithms in the curriculum? Now, I'm also reminded of some work I think Albert Lionel presented this work at SIGSI about kind of like thinking about the overloaded nature of data structures course. Because in a lot of curricula here in the US, at least, in our computer science curricula, we have data structures and algorithms, but it's doing multiple things in the curriculum. Like it's not just a conceptual or algorithmic introduction to hash tables or binary search trees or balance trees, but it's also students' first exposure to larger scale programs, to software engineering skills, to questions about modularization that go beyond just one or two classes. Maybe there's a larger interaction between a larger system. So for me, my own course is also situated within that context of like, I'm teaching, even more interestingly, I'm teaching non-major students, so students who are in our electrical and computer engineering program or informatics program, or students who are more interested in the design, or even students who just have a passing interest in computing and want to go deeper into it. And so I ended up serving a pretty broad group of people who aren't just interested in software engineering in my context. So thinking about all that together, I feel that the value of a data structures and algorithms course is really a lot of things. Like it's giving students that bigger exposure to larger code bases, that grounding and foundation in thinking about data, how it's organized, how to apply things like these conceptual properties like mathematical or data structure invariance to reason about things, provides ways of understanding this process in computer science that's oftentimes focused on efficiency. You're using tools like asymptotic analysis, or maybe you're using experimental analysis, like benchmarking your code. You're developing these broader tools for reasoning about code beyond just the immediately obvious properties of how it's written, its internal correctness, or its behavior, its external correctness. So I think all those
Yeah,
things are skills that are useful in a future. So I'm happy to
yeah.
dive deeper into any of those if you're curious.
Yeah, I was asking that because basically more and more people are saying that this kind of lead code interviews will eventually be replaced by more hands-on, software engineering interviews where you build a function or you build a feature, for example, right? Or perhaps some more system design interviews because, of course, these kind of skills like specification, orchestration of agents, all of these are new skills that are focused more on evaluating the architect who orchestrates solutions. So yeah, I was just wondering, what do you think about that?
Yeah, so you're bringing up a lot of tensions about how data structures, concepts, curricula is used in the real world, and starting from like the interview phase through to what would it actually look like in the real world in students' day-to-day practice as software engineers. So I think there's interesting dilemma there of like, I think even right now a lot of companies are experimenting with changing up their interview processes. So if you haven't been looking around or focusing as much, there's I think a lot of companies are, as part of their interview process, evaluating students on their ability to use AI, on how they're using it, on how they're going beyond just copy and paste the prompt my boss gives me for the spec, and thinking about how are you managing things like the context window. How are you, for example, employing tactics like test-driven development to have like a useful harness for the agents to do their own thing within the frameworks and the specification that you've defined, right? And those are things as an engineer you have to actually, at least in the current models, have to explicitly ask for. You have to actually say, I actually want to have this TDD, test-driven development skill. I want to actually use this in your development process. I want to set up CI/CD and make that very clear to the runner, to the agent, how to run that CI/CD or do things in more of an effective working loop. So I think a lot of employers are looking at these kind of broader process skills around things like you were saying, agentic orchestration, agentic engineering skills like that. I would say even within the current regime or the previous regime of like kind of a leak code style interview, and it was, I guess I always kind of struggled with that. Like I think my own mindset, the data structures and algorithms course, like I've already claimed, is very overloaded with different things it's trying to do. And leak code was another one of those things that we were trying to do because there was already kind of very natural connections. I think from a conceptual standpoint, it is useful to take data structures and algorithms to prepare you for leak code style questions. But there's still so much of like training your fingers, training your mind to translate the concept of like, oh, I think this is kind of slow, I should use this other data structure instead, to like, wait, but I have to think through like, how do I actually implement a try again? What are some of the nuances in that approach that I feel like you have to, as a student, train up for? And maybe there's a similar analogy there with this agentic shift for the interview, at least, of like, maybe you do have these general engineering skills you're getting through the way that data structures and algorithms has this conceptual component and large code-based component, but you have to actually train for it more carefully. And that's one of the things I've been exploring in my work as well.
Interesting. So you mentioned your DSA course. I think it's a good time to talk about that. So I've sometimes heard this argument that data structures and algorithms are taught similarly at most schools. The topic stays largely the same. What really differs is the group of people learning there together, right? Because there is, and I agree that sometimes the difference. I mean, going to the classroom physically, right, in person. So that the difference is like you can feel this like kind of osmosis that comes from being surrounded by motivated peers. Like you can feel this intellectual friction, and I think that is fundamental to learning. But it can also shape our identity as a CS professionals. What do you think makes a DSA course truly stand out?
That's actually a really neat and different perspective that I wasn't thinking about beforehand. But now that you bring it up, it's a really powerful point. This idea of like frictions, this idea of like, what is it that a student gets out of that course beyond just learning outcomes that are even like the high level ones of like be able to work with large code bases or be able to process, analyze, do some kind of skill. There's this larger process you're arguing for, which is that you're creating these kind of frictions and students are able to learn how they overcome those frictions. And that's a really valuable skill in general. I totally agree. I feel like, especially, I guess my secret is, I'll tell you a story. So I did undergrad at Berkeley, and one of the things that really stood out to me looking back at that experience is that I really felt like I didn't actually learn all that much after my data structures course. Because if you actually think about it, like you've learned all the core like analysis skills, reasoning skills in the data structures course. You learn how to tackle new information, how to think like a computer scientist. And then everything else you're taking like security or architecture or organizing computer systems or even like further algorithmics. It's just like, oh, I'm able to apply that in a different context, but I could have also gotten that fairly well through online resources, I feel personally. At least for very motivated students. So I found that to be an interesting tension. And I think that goes to exactly your point that you are gaining as a student so many of these key skills and these foundational ways about approaching things. And that friction is important to experience, because if you don't get that friction, then you won't have developed that experience, that intuition, that intrinsic ability to know how do I move out of this difficult problem state to a more productive approach, right? And a lot, I think back to this like funny meme. I don't know if it's funny, but like there's a meme in industry right now called taste, right? This idea of, oh, what really matters in an AI future is having good taste about what problems to solve, how to engineer solutions. You have to have good taste. How do you develop taste if AI is doing that work for you? I think it has to be that you have to have useful, productive frictions. And part of my course design is actually designed around like when I think about this productive friction thing, I think also about Manu Kapoor's productive failure work, and I try to apply some of his productive failure methodology in my own classroom. Now, the interesting thing about productive failure is as a methodology, as a teaching practice, it kind of is an interesting way to do active learning. So I don't know if this is a tangent, but if we continue down this pathway of active learning, one way to organize things is instead of like showing students how to solve a problem first and then asking students to solve that problem, productive failure posits that you should have students run into difficulty first in the classroom, and they should feel like and really sit there with like, I don't really know how to solve this, and that's an okay feeling. But then when they then get that feeling of I don't know how to solve this, and then they see someone else, like either you or a peer, work through the problem, they'll have a better understanding of how to use your information, your problem-solving process, to address whatever friction, whatever boundary, whatever challenge they ran into on their own work.
Yeah, and it's interesting because I'm developing a tool now that is more like a programming assessment tool, and I gave them these problems with AI chat integrated there, and basically I'm recording all of this data in my backend. I can access these reports on through simple query on my Cloud Code, and I see that many students now, maybe I don't know, 1 or 2 years ago it was not the case, but now they are explicitly saying to the AI, don't give me the solution, right? I want to understand the problem and give me the step by step, or explain me this concept first. So I love that they are also developing this self regulation, and also they are not delegating understanding completely, right? Because this friction, this effort, right, struggling, is also part of the learning process.
Yeah, I really appreciate your cognitive framing about this, because I feel like a lot of times we're focused either on like the failings of students or the technology itself, but there's a lot of ways in which we can actually think carefully about the pedagogy, the design of the learning environment, the design of things to help bridge that gap that we're seeing with like, how are students using our tools, using the AI tools, how are they addressing our assignments, and like how can we kind of fix that gap if students feel like, oh, am I actually able to learn effectively with the recommended ways the instructor's using, or should I use my own ways to learn what I want to learn out of this class? So I think students are discerning in that way, in terms of like, they can kind of recognize if they're getting what they want out of the class through the way you've designed your assignments, through the way you've designed your pedagogy.
Yeah, and then part of this learning experience is making classes more engaging, right? And I love learning concepts visually, especially DSA topics like big O complexity and other important data structures. There is a project in the computing education community called Bridges that wants to bring real-world data sets into CS courses, and there's also a very interesting tool from Georgia Tech called CS BizTool. And I also recently bought this book called The Computer Always Wins, which suggests some playful ways to explain some data structures and some concepts. I'm interested in your perspective on using visualization in the classroom, or maybe how can we make DSA classes more engaging?
I don't know. I feel like that's an interesting challenge. There's on one hand, the one framing is like there's engaging at the level of like what's happening locally in the classroom right now. But I think there's also engaging from this almost more of an intrinsic motivation sense of like, are we seeing interesting applications? Are you as a student motivated by the problems you're solving or the problems you're facing right now? So for example, in my class, we have a mix of things. So we have, for example, this broad high-level goal in this class of implementing efficient approaches for this map application. So imagine like Google Maps, Apple Maps, but it's a toy project. But it is actually, you do actually have a web app here, and you are actually making something that's like, wow, I can really see myself building stuff like this in the future. And I think that's something that's really intrinsically motivating for students. And they can start to appreciate like what's the different turn with data structures. It's not just about getting the program to work, but it's about getting the program to work efficiently and effectively around user-centered design, around user-centered elements of the experience too. But then within the classroom, in a day-to-day moment, to your question, we do a lot of things that are like hands-on. So we're using pen and paper a lot. I found that to actually be a really good technique in this AI era. I think oftentimes students think that they can learn really well with technology in front of them, but I've actually found I think pen and paper is really the way to go. if anything, to help with reducing distractions, but I think it also helps with really, I think, having more of a flexible note-taking device than just typing things down. Because with typing, you have to really formulate things into like lines, and there's not an easy way to be able to say circle something or add a annotation to something in a diagram, right? Or draw something easily. So I think to your point, I think actually a lot of those things are about not just I'm presenting something to the students, like here's a visualization, that's really cool, but also how can I get the student to generate the visualization? How can I get the student to draw connections physically on paper or somewhere else that illustrates their thinking, that helps them learn something new or connect ideas that they hadn't seen connected before? One of my favorite activities in data structures, for example, is just earlier this week, we just finished our first major module on search trees and sorting. And I teach those two topics together because they're really connected in an interesting way. If you think about how search trees rely on sorting and underlying in-order traversal in the way elements are organized in a search tree, but also how like sorting is, in a sense, you can think of as almost like a search tree data structure, but played out over time. Because if a search tree is kind of organizing things in order, then like the simplest search is like tree sort. You can just throw all your items into a search tree, iterate in order, and you're done. And we try to draw all of these parallels between you've seen this search tree, what is the corresponding sorting algorithm? I think that's an incredibly eye-opening way of like looking back on a module. And I feel like activities like that at the end of a module can be really fascinating and powerful, especially if you design the module around like, wait, we've not only learned about all these disparate data structures and algorithms, but there's some weaving connection between all of them that explains why I've sequenced these topics in this order.
Yeah, it's funny because we are going back to the pencil and the paper, right? A student, because I think a student who never debugs a program and who jumps in straight to asking an LLM to fix it, they are learning how to follow the map, but the map is not the territory, right? And for example, in data structures, knowing, for example, bubble sort, right? That compares like adjacent elements is very different from having implemented bubble sort. Then for example, insertion sort, right? And feeling that why these numbers. Why one takes, I don't know, seconds and the other one takes milliseconds on a list of n thousand elements or something like that. Yeah. And the same with algorithms like Dijkstra, right? So yeah, it's not the same doing it first by hand and feeling the moment where your goals diverge or no. It's like, okay, I got it, right? So this feeling, I think, is also very interesting in this DSA.
You actually brought up a super interesting example about like implementing and comparing different sorting algorithms. I actually have some challenging thoughts about that. Like something that I feel like I hoped would be more of a commonly accepted practice, but I feel like it's still not very commonly accepted, is this practice of, in my classes, in my data structures class, I do not have students re-implement any behavior that's provided by Java, because we use Java. And that means I'm not asking them to implement sorting at all. Like we just talk about it like algorithmically, conceptually. And then what I end up doing is we end up applying sorting in creative ways to solve, for example, problems like autocomplete. Autocomplete in a search bar, right? Which is a nifty assignment from 2016. I think Kevin Lin was the author there. But we try to solve it from different ways using, for example, sorting as a tool that's provided by Java. And then we compare the different approaches of what if I put things in a sorted array and then use binary search to find the first match? What if I put things in a tree set and then how would that compare? But one of my arguments is that I think in the real world, people aren't going to be asked to like re-implement a sorting algorithm. Or if it is, you're going to be talking about re-implementing a very niche, high-performance sorting algorithm like erratic sort that's not already provided by the library, right? And even then, you'd probably be looking at like sample implementations, or you'd be asking GenAI nowadays, right, to do it for you. Once you have the idea of like, there's a performance problem, or there's that particular gap in terms of what we could do to address that performance problem. So I think to that point, in this whole overarching conversation of like, what's actually relevant, I feel like we do need to look back at our way of teaching data structures and ask like, will students actually need this skill? And even if it's a historically useful concept like sorting, I think we can teach it in a conceptual way. Like, here are the conceptual skills. I'm still asking people to do asymptotic analysis. it's almost like a proof of like how well they understand the algorithm, right? When you do the asymptotic analysis. But I also think of it as like once you have that concept, once you have the idea of that sorting algorithm down, how would you actually want to demonstrate that skill in the real world? You'd probably use the sorts to help you speed up a larger part of a system, but you want to think carefully about when am I employing the sorting? Are there better ways to do it than sorting the entire structure over and over again, right? And I think that those are different kinds of questions than the traditional questions about how fast does my bubble sort run. But I think that they're also valuable questions, and I think they might help shift us toward a place where we're more aligned between what we're doing in the classroom and what students want to do in the future.
Yeah, let's switch a bit more the topic. I think we can talk now about online in-person classes. I think it's a good topic because I'm not sure where when it comes to DSA, there's a clearly better approach or any strong arguments to choosing one over the other. I have my own experiences learning and teaching both online and in person. I love the resources you shared with Josh Hack from Berkeley. I think he does a really great job sharing all of these resources online. I've seen, you have used in your classes. I also really enjoy watching this professor from Duke called Owen Astrachan,
He's in the 60
which
community
are
too.
available on their course website, as well as I met this guy from, well, I don't know if he was in the last 60 in St. Louis, but Mark Liffiton from Illinois Wesleyan University, he also has really interesting resources online. So I don't know, what's your take here? So I don't know if you're teaching now online or in person. Can you tell us a bit more about that?
Yeah, so my classes and pretty much most classes at UW are in person only, and that's an interesting discussion. I feel like for sure. I think that there are trade-offs there, right? Like I think, for example, I don't even like offer synchronous hybrid opportunities. So it is really truly just here's in person and this is what we're offering. I think partly there's a few different reasons for that. I think for one, it was also a bit of a reaction coming out of COVID. I think when we were coming back to in-person instruction, I think for many students, they felt like, oh, I was still able to learn what I needed to learn through online. And we tried, for example, several hybrid offerings, or I at least tried more hybrid things. But I found that that really encouraged students to step into a bad habit of like not showing up to classes, not even watching the recording later or engaging with the material, engaging with the practice that I have in class, which I have lots and lots of practice using productive failure, peer instruction, other active learning forms. And when you're not doing the practice, you're not experiencing those difficulties, right? The challenges you were talking about, then you're not actually able to learn the things that we're expecting you to learn. And then you struggle on exams, you struggle on assessments. So I think part of it was just kind of this broader communication thing of like, we really think that we are doing a lot of practice in class and that practice is really important. And the best way to make that clear to students that the practice is important is you have to come to class. You have to come to class in person in particular because there are, the way the classroom is set up, it makes it hard to do online well. So I say the synchronous hybrid, it's not a great technology setup for us because you end up like really privileging the in-person experience through the way our limitations of the way our classrooms are set up for the most part. And also I think there's an element there of like, can you be accountable for your own learning? We've also found that I think university is a place where students are still trying to figure out how do they organize their lives? How do they organize the structures they need to be accountable? And at least for us students here at UW, I've realized actually students at different universities are actually quite different in terms of how they are thinking about why they're here, how their different study strategies have prepared them for this moment at university. But certainly for university students here at UW, I do feel that the in-person environment really does help with things like even attention and whatnot and focusing on tasks and being able to be accountable to themselves about what they're doing.
Yeah, so you mentioned challenges there. I want to go deeper into that because this summer I will be doing a doctoral research visit at Aalto University in Finland. And while I was, reviewing his work, one, PhD student, I think he already defended his dissertation. It's called Arturi Tilantera. He's currently researching students' difficulties in learning computer science, I think particularly basic algorithms. And his dissertation explores misconceptions and some challenges, I think very relevant to those teaching this course. And I also see in my software design class some problems with some students can ace a multiple choice quiz question, but they cannot solve a basic problem, right? So this leads me to the difference between what I mentioned before, knowing the map and not knowing the territory, right? And with AI, I'm wondering if it reduces this misconception or actually reinforces some incorrect mental models.
Ooh, that's a tricky question. And I think there's also a connection there with the question you were bringing up earlier about how has the way students use the AI, how has that changed over time? Because I think we're also observing
Yeah.
that change over time happening too. And I think that's a very astute observation you're making. I think students are thinking more carefully and critically about how they're using it for their learning, especially when you have courses that are now bringing back these accountability mechanisms like exams and whatnot. So, yeah, to your question, I think is it a shortcut for learning? I really like Mark Gusdale had this great quote about the difference between cognitive offloading and cognitive outsourcing. Because a lot of people talk about AI as cognitive offloading, but cognitive offloading are things like using notepads, using paper to help you kind of offload some of the information, some of the cognitive demand on your own senses, right? Versus cognitive outsourcing is just you're not even worried or thinking about that process, right? And so I think there, if AI can be used in a more strategic way for students, it would be to think carefully about am I outsourcing this thinking? Or is it actually helping me think more deeply about this topic? Is it helping me identify a gap in my knowledge? And if there's a gap in my knowledge, I think that framing itself is a little interesting because a gap in your knowledge almost assumes that you already know that topology, you already know that territory, like you were saying. That assumes that you know what the field is like. And there's a difference between, I think, doing research and being in industry versus being a student. Because being a student, we know what the field is like. We know this is what the curriculum is going to be like. We know where the gaps are. And that goes to Ardo's point, the Alto University point, about we know these gaps in how students are understanding things in Dijkstra's algorithm. I think I've read some of the papers too, about how what are some of the students' common difficulties, right? But that's different than in industry or in research where you have to you don't even know what that lay of the land would be like, right? I think there's a lot more uncertainty there where Gen AI can help you fill in those uncertainties based on kind of its just large understanding of the internet and human knowledge in general. Versus I think with AI helping you on things that are well known, there's a question there of if it's well known, what was the gap that you had that made it so that I couldn't, as an individual student, figure out that gap on my own? What was that piece of information that's missing? And this is a strategy you probably already used in your office hours, right? Where you're helping someone out on something, is helping a student out, and you want to leave them in a place where they're not dependent on your support. And so maybe you do a debrief at the end of the office hours with that student, and you go, hey, what was the information that you wish you would have known? What was that fact or that question you should have asked yourself to be able to help navigate that territory better? And I think that's the skill that I hope students would be able to think to ask, and that I think also Gen AI tends to shortcut, that it'll fill in the gap for you. It'll write the code for you. It'll do whatever you need for you. And it's more about this productivity-oriented mindset rather than a learning-oriented one.
Yeah, interesting. So Kevin, just finishing our conversation, I want to ask you about your last article in your blog called Reimagining CS Education. I know, maybe you can share us a couple of ideas you think are worth discussing further with the community.
I mean, there's a lot of ideas in that talk. I would say, I think if you're looking at or thinking about that talk, it is still fairly narrowly framed. I think if you want to think about what we could do in CS education, as much as I've titled it Reimagining CS Education, I still think of it as a very conservative talk in terms of what it's arguing for. In terms of just arguing for if we thought about our curriculum as a sequence of courses around these different subfields and having these kind of developing students more narrow expertise within a certain number of subfields, maybe a student becomes more of an expert in security, for example. I think there's still a place for that. And I think that talk is trying to figure out how do we angle for this kind of current reality type of conservative mindset on what CS education can look like. I think an interesting idea within that narrow framing of what it means to reimagine CS is that there are many components that you need to contend with, really, when you're working with Gen AI. It's not just like the technical skill of like I was mentioning earlier, agentic orchestration, agentic engineering, all these buzzwords about how do you use an agent effectively. I think it's actually more than those skills because there are also things like the motivational aspect we've been talking about today, right? Like how do you have the intrinsic motivation to continue down this path? I think a lot of students are experiencing right now, seeing like, are my jobs disappearing? Where are the jobs that I was working toward? And I think having a clearer message about what that motivation should be in this world where I think students are hearing a lot of signals about, hey, companies are cutting back, companies blah, 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 blah. How do we kind of navigate that? How do we help students navigate that? How do we help students find and build their own confidence, develop their own pathways? And I think some of it might be that there's a less established pathway to engineering nowadays. That maybe in the future, I think that there will be more of a bifurcation, if not a trifurcation or other ways of dividing what is typically a software engineering role. I think we'll have many smaller versions. Like you maybe have some software engineering with more of a UX spin, software engineering with more of a product management or business consulting spin, product management with more of a security or advising or legal side spin. And I think having more of those spins and thinking carefully about what kinds of areas you want to develop your own skill set in will be really a lot more valuable because Gen AI will enable the proliferation of more of these kind of more niche software engineering plus type of experiences.
Yeah, I heard Chris Ladner recently saying we don't need more software, we need more quality software, right? And I think I cannot think anyone better than us, right? And software engineers, computer scientists, to deal with these kind of questions about quality and about verification and about specification and all of these new skills. So yeah, I wrote a lot about this in my newsletter, Computing Education Things, and on that, computer science is not dead at all, and teachers and CS educators in general, we have to learn more about this world, but we are in the right situation. So yeah, thank you so much, Kevin. I leave the blog post in the description along with all the resources we talked about today, and really appreciate your time. What's the best way for people to connect with you?
Definitely take a look at my website, kevinl.info. It'll have a blog post, my most recent one at the top, which at the time of this podcast, it's the Reimagining CS Education talk. I'm certainly quite happy to actually give that talk. So if any of you are interested in like hearing me give that talk to your university, whether remotely or maybe you want to pay to fly me out, that'd be great too. I'm happy to do that. I actually have a lot of time off this upcoming year for a sabbatical. So happy to very much give those talks and try to work with faculty, try to understand what difficulties faculty are facing. I think some of it is also upskilling. This kind of question of like, okay, yeah, so Gen AI is happening now, but what can I do? I'm so busy. I'm so like overwhelmed. How do I kind of fit that within my schedule? What should I learn even?
I recommend you, Kevin, looking at my last episode with Borja Sotomayor from University of Chicago, because we talk about how do CS departments support their teaching, and it's a very interesting study.
Yeah. Yeah, I think part of it is it's so frightening how fast things have moved and how a lot of this information has not been like enshrined, or there's not like a textbook, or a lot of the research is moving so quickly and a lot of it's actually happening on the industry side, right? Like the people are just using the tools and they're learning how to use it more effectively and they're sharing it informally. They're setting up their own kind of AI engineering conferences that academics haven't historically gone to, right? And so I think that's kind of really upending the historical role that academia has had to offer in software engineering and practice in that way.
So that's all for today. See you in the next episode. And again, thank you so much, Kevin.
Yeah, of course.